Hey everybody, back with part 2 on this Extech 382270 little repair series. This is just a quick little intro. After I got power supply number 3, I got both voltages working. We went and did a current, about to do a current test and ran into some problems. So I'm going to cut to troubleshooting part power supply number 3. And then we'll come back in a little bit. Alright, I was getting ready to test some stuff, testing the amp loads and stuff, and I managed to break channel 1 again. But I'll show you what I was doing. To do constant current, you need to power it on, right there, and then you need to short, turn your voltage all the way clockwise, like that, to the right, and your current all the way to the left. And you see you have constant voltage right there, and we are going to short channel 2, and then as we pull it, oh, hold on, I need to, yeah, that's right. Oh, I need to put the output on. Alright, so now we have our output. Overload light went out, and now we're adjusting our amps. Now this is supposed to be rated to 5 amps. I'm just kind of going slow. There's 5 amps right there. So no problem going to 5 amps with that. But if I come over here, well now actually if I turn my current all the way up, I have my 30 volts. Everything's adjusting. But on this side, oh, it's working again. Alright, that's good news. I thought it was not working. Interesting. Alright, let's check our current. Turn this all the way up. Channel 1. I thought I heard something like smoke. Yeah, see? Oh, you know what? Maybe it's this. Not getting a reading on that. I guess it's working. I have no idea. It shut down on me before. Interesting. So it seems like it's working. Wow, that's so weird. Alright, let me pause and come back. Something's jacked up. I'm on channel 3. See, nothing. I mean, I'm on channel 1. Channel 3 is fine. Channel 1, current's all the way up. No voltage again. I don't get it. It did not like being shorted like this one over here. Turn that all the way up. This all the way down. Short number the positive terminal to the ground to negative. See, it's working fine to adjust the amps. I don't know if it has a safety thing at 5 amps or not. Yeah, that's as high as it goes, 5.1. So I'm going to take this thing back apart, damn it. I'm not sure exactly what's going on. I pulled the board out, resoldered everything. It works again. It's like it was shutting down, and it takes a while for it. You have to power it off and then power it back on to get it. But now I have it going through a 10 ohm load, 20 volts, 2 amps. That's roughly about right. And it's going up. Obviously it's not going up to 4 or 5 amps, which is interesting. I mean, it seems like it's working. I don't know if it's the relays that are acting up, or there's a LM324 back there as well. I also don't know when the fan will actually kick on. I mean, I definitely feel things. I mean, I feel it. I smell it kind of getting warm and things heating up. This right here, the heat sink is definitely getting hot as hell. I'm going to let it run for a little bit and see. Yeah, I'm messing with this thing, and it seems like I got it back working again. It's almost like the current adjustment is like acting weird. Alright, well now it's screwed up again. Something is not right. The other thing is, listen to the relay when I actuate the left-hand side, channel 2. It's very loud. It's very loud. And when I do this one over here, well, obviously it's screwed up now for some reason. But then it does come back. Why is that? Is it a cold solder joint? Is it this pot is doing something weird? It doesn't make any sense. I took off the knob and now I'm doing the short again. Alright, going up 2 amps. Boom. Something just happened. And I don't get it. I wish I had the schematics for this damn thing. I don't even know what parts are in with that. I just had a hunch based off the sound. I swapped relays. I took the relays from here, put them in over there. I don't know which one's bad, but now my right channel seems to be working fine. And my left one is not working. I think something's wrong with one of those relays. That's channel 4. Yeah. Because that's the only thing I changed. those relays right there. Yeah, I'm gonna have to look up, see if I can order some. I'm gonna do my constant current test, so shorted channel 1 there. So it goes all the way up to 5 without flaking out or anything. It was definitely those relays. One of those relays is having problems. Alright. Alright, so this is while I'm waiting on parts to arrive for power supply number 3. I need some relays. I figured I'd break out power supply number 2. This one has a bad 10,000 microfarad capacitor, so I'm still going to have to do the same thing, pull this power board off and cut off these transformers and repin the transformer outputs and stuff like that so I can actually get the board out. But before I do that, I figured we'd do the same constant current test. So turn voltage all the way up, current is all the way down. We're going to short channel 1. And then turn on our output, and we should have our amps increase all the way up to 5 volts. And I'm still waiting for the fans on these things to come on, so I don't know if the fans are actually working or not, or if it's, I think it's temperature sensitive or something, I'm not sure. But there you go. I can go all the way to 5.26 amps with my constant current there. So that looks good. And we'll do the same thing for channel 2. Voltage is all the way up. And nothing is shutting down. I also don't hear the fan coming on, so I don't know if the fan's working on any of these. Let me see if I can. Yeah, it did get pretty warm, the heat sink over here on the right side. I don't feel anything on the left. I might leave it like this for a little bit and see if I can get the fan to turn on. Just running it at 3 amps for a while. Let me do that and I'll come back. Alright, that's a good test. The fan is actually spinning now. I did it at 128 and it's 132 now, so it took about roughly 3 minutes. I didn't really put it on a timer, so, and then I hooked up number 2, channel 1 with the constant current as well. So I just wanted to make sure that fan did come on, and it does run, so just took a while, so it must be temperature sensitive. So let's go ahead and test these under load as well. If I unhook these, alright, there we go, nice. And then I'll go ahead and wire on some of my resistors here to test the amperage. But this thing looks like it's working fine under load, obviously. Alright, I came up with a little plan on how I want to test this and just used an online ohms calculator. So the 3 to 6 volt line, channel 3, it's good for 3 amps. I'm going to test it with a 2 ohm resistor and around 3 amps. I'm not going to go higher than that, but it's going to be about 20 watts, so I have resistors for that. For channel 4, I'm going to use 15 volts, 15 ohms to get a 1 amp load at 15 watts. This is testing basically to the maximum there. And then for channels 2 and 1, I'm going to use a 12 volt test with 3 ohms, 4 amps. At 30 volts, I'm going to use 10 ohms. That will put out 30 amps because I don't have, it's going to get a lot of wattage. So I don't have, the highest rated resistor I have is 100 watts. So I'm not going to probably keep it there for very long. And then 5 volts, 1 ohm, 5 amp load, 25 watts. And that'll test channel 2 and 1 to the fullest there. So I have it hooked up to a 3 ohm load. Current is all the way up, channel 2, and let's see here. What am I doing? 3 ohm load, I'm going to 12 volts. Oh, I gotta turn it on. Now I'm not checking to see how accurate the amp reading is by putting my meter in series there. I could do that. Oh yeah, I already went above that. Let's go to 12 volts. And it's supposed to be around 3 amps. It shows 2.7, but that's fine. So it looks like it's pretty good as far as that goes, and my resistor will probably get pretty hot. Yeah, I can feel it getting kind of warm. Should I put my meter in series there? Yeah, let me do that. Positive, going to my positive. And then through my meter, amps, negative to the resistor, and then back into channel 2. Let's go ahead and hit our output. What? Milliamps. Should be amps. Oh boy. $12 milliamps? That doesn't seem right. What the heck? I wonder if my meter, it has the batteries low. I wonder if my meter's acting weird. Alright, I plugged in one of my cheap multimeters. I might need to replace my battery or something's wrong with my Bremen. 2.6 amps, 2.61 amps, so it's reading exactly what that meter is at 12 volts. So that's good. Let me replace the battery in my Bremen. Alright, replace the batteries. No more battery warning there. Turn it on. There we go. 2.63 amps here, 2.626 on my meter there. So I would say that looks pretty good. Yeah. Alright, cool. So we're good there. Let me come back and do some more tests. Alright, channel 1, same test. 2.6, 12.2, 2.62. So within a hundredth, right? A hundredth of an amp reading compared to my Bremen there. $12 volts, 2.5. Now, according to Ohm's law, I think it should be closer to 4 amps, right? I don't know. Maybe the Ohm's law calculator is different, but this is reading correctly. Alright, let's go to 30 volts on a 10 ohm load. Alright, we're going to go up to 30 volts on 10 with 10 ohms. Should be around 3 amps. And I have 2 5 ohm resistors wired in series. Let's go ahead and hit our output. So you guys can see that. There's my 30 volts, 2.5 amps, 2.54, 2.56. So a little bit off, you know. I don't know which one's more accurate. I would think this meter's probably more accurate. I don't know how to, there's probably some adjusters on here and don't have the service manual, so I'm not going to do that. I'll come back and run it through the other one. I could probably go all the way up, actually. There you go. Maxed out, 30 volts. Alright. Unplug this. Do number 2, channel 2. .539, 2.54. Actually reading pretty. Whoop! There went the fan. Yeah, so we probably could adjust this. Again, I don't have the service manual, so it kind of sucks to do a full-on adjustment. But especially, I need to recap it anyway. All right. So I would say channel 1 and 2 are both fine. Let's come back and do a 2 ohm load on our channel 3. Alright, I have channel 3 enabled. Oh, I already have the output enabled too. And I got my, whoops. Let me hit that off. There's my 2 ohm resistor. Try and do this with one hand. Alright. Turn all the way down. We should, at 6.6 volts, we should have almost 3 amps, which is like its max. Man, my ohms calculator must be wrong a little bit. I don't know. Or maybe the resistance is slightly different. One 1.9 at 6.8 volts. That's good enough for me. I don't need to push it to the maximum. Alright, and then we need to come back and do 15 volts, 15 ohms at 1 amp on the channel 4. Alright, I have 2 5 ohms and a 3 ohm in series, so it should be around 13 ohms. You know, with the length of these cables, it's probably adding additional resistance. I didn't measure it, so, but good enough for government's work. Alright, let's come to channel 4. That's a half of an amp. Half an amp at 7.5 volts. Getting pretty close to the full amp right there, 13.6. So I would say it's working under load. Now obviously we can measure ripple voltage and crap like that too. I might, should I do that? Now I'm interested. I need to get some different kind of test leads and stuff to make this easier. Yeah, measuring ripple voltage would be useful, I think. Alright, one of the other things I wanted to test is wiring it up in series. So you take channel 2 positive to channel 1 negative. I linked to a video in my first video that shows this. And you want to have the in series here. So you're going to push this one in and leave the second one out. And channel 1 is the master. So channel 2 should track channel 1. And then you turn it on. And we'll adjust the voltage here. So what you should be seeing here on my meter should be, because I'm in series, I'm getting double the voltage. If I go from this negative to this positive, channel 2 negative to channel 1 positive, I should be seeing double the voltage on my meter versus what you're seeing here, which is kind of interesting. I would have thought they would actually double it on the display, but it's really like 6.2 plus 6.2 is 12.4. That's, 6.2, 6.2, 12.4. This is in series. So we're getting double the voltage. I still believe at 5 amps. I'm not sure. I have to read the manual. I'm not going to test the amperage on it doing it this way. .0 volts. 61.5, 61.5 equals 63. So, right? That's 62, yeah, 63 on the nose. So that's pretty good. And in parallel, I can't remember exactly how you wired that up, but I'm not going to actually test that because I need different kind of connectors, so I can, different banana plugs, so I can actually do different little things, and I don't have those. So I might save that for the end of the video and order some on Amazon or something. Regardless, this power supply to me is fully working. This is power supply number 2. I am still going to take the board out so I can replace that cap, that 10,000 cap, and then in case we do want to recap it, it'll make it easier to pull this thing out in the future. So I am going to take that apart, but no need to do anything on the front. The pots work great. There is a little bit of damage here that I super glued back, but I'm not going to screw with it much more than I already have. So, alright, that's it for power supply 2. Okay, power supply number 2, got the board out, repinned the transformer outputs there. There was only 2 that I needed to repin out on this one, so just the 2 headers right there. And it should be fine. I think the headers that they had on there weren't very good, but I did test this 10,000 microfarad cap, which seems like the top is about to pop off or vent, and it does test okay with ESR, which is kind of crazy. Yeah, I mean, it tests fine with ESR. I'm still going to replace it and measure it out of circuit, the capacitance. I tested all the caps on this board, and they tested fine. So I'm not going to replace any of them or anything. But I think I do have a 3300 25 volt to replace this with. Regardless, even though it's, yeah, I'm going to pull it out. I'm testing the capacitance of this, and I can't remember what my meter goes up to, if it even goes up to 10,000, but it's testing at 8.06 millifarads instead of microfarads, or is that microfarads? Beats the hell out of me. So let me figure out. I gotta figure out if my tester's working right, but I think it's testing out of spec. Yeah, I just noticed. So anyway, let me think. I hooked up a 1,000 microfarad cap, and my meter works fine with 1,000 microfarads. I just wish it would read overload if it was going to read overload, if it couldn't read it. But if you put it on, like this is a 4,700 microfarad cap. Is it actually trying to read it? 4.65 millifarads, right? Which is above. Maybe it is trying to read it. Yeah, interesting. I'm going to get the spec sheets out on that thing. Because when I try to do it on my Proster here, screwing with my I'm learning. Screwing with my meters. Let's see. My Proster, if I try to measure a 4700, see it goes like over limit, and it only goes up to 2000 microfarads. Let me read what this actually goes up to. Yeah, I'm an idiot. That's 8 millifarads, which is 8,000 microfarads, or farads, or whatever you want to call it. So it's plus or minus the Bremen 235. I think it's within 4% or something like that, and I think that's probably off. So it's testing out of the value is not good, but I don't have a 10,000 microfarad, and 8,000 is better than putting in a 6,000 probably. So I don't know. I'm gonna put it back in and just leave it alone. If Arcade Buffet wants to swap it back out, he can. Okay, putting power supply number 2 back together, and I was going to use like a cloth washer to, try to shore up and spread the, the force of screwing this in, but there's not enough clearance to get the lid on if I use washers. So I don't know. I think it's just hopefully the super glue holds up or something. I guess you could kind of hot glue, put some hot glue around there, but then that's going to impact it too. I don't know. It's kind of weird. Maybe on just this side, put some hot glue right there. I'll do that actually. Okay, looks good. This is nice and sturdy now. Power supply number 2 is done. I did get some parts in the mail after being gone for a week. These are the replacement relays that I had, and they're going to be replacing these right here. You can see that. Actually, I guess this way. That's what they're replacing. Remember, I had swapped in this power supply number 3, I swapped the working relays from here. I don't know which one's bad or if both are bad, but I'm going to take both of these out and put in these new ones and see if our channel 2 is back. So let me do that off camera with my desoldering gun and soldering station there. Okay, got the relays replaced. These are the bad ones. I'm just shaking it. This one seems... See, this one is making some noise. I don't know if that is an indicator. I might have to look up to see how to test those. This one seems like it's okay though. It's not making any noise when I rattle it. Let's see if this fixed our problem here. Boom. There we go. That looks good. Let's go ahead and do constant current. And we're going to short number 2 here. Yep, nice and smooth. And it's not shutting down or anything, all the way up to 5 amps. So that looks good. Let's go over here. No problems. So I was messing with the, the potentiometer here, but that's not the problem. See, it wasn't. There's nothing wrong with this thing. All right, I figured I'd measure ripple voltage. I have about almost a 3 amp load, 30 volts, and I'm at 0.03839. right there. I will check the other one here. It's kind of hard to do this with one hand here. .39 on this side, so that looks good. So just showing that real quick. Okay, I'm going to test this relay real quick. The 2 pins on the outside, let me grab one here, upside down here. On the 3-pin side, these 2 outside pins are the coil pins, and then I guess these are the switches or the relays right there. So on this relay, the coil tested good. I measured resistance there, and if I go from the middle pin right here to this pin, whatever that pin is, I have continuity. And so what I'm going to do is power up my coil and throw some voltage to it. Yeah. I can hear the relay clicking. I think it's like a 24-volt relay, so. And now I have no continuity there, but I have continuity on this pin. And then you turn it down. And I have no continuity there, but I have continuity there. So let me test the other one and see what it behaves like. So on this one, this is the other one. No power, as you can see right there. No continuity to this first pin, upper right. No continuity there. Let's apply some voltage. I don't even hear anything. I'm going to go out to 20 volts. But nothing. I think this relay is bad. Because with no voltage, I should have continuity up here. Let me check a brand new one. This is my brand new one. Continuity to pin 1. I just heard the relay click around 13 volts. No continuity there. And we have continuity over here. If I can actually get this to work. There you go. But no continuity there. And if I turn it down. Oh, whoops. I was going up. It's only got 24 volts coil. Yeah. Turn it down. Oh, I just heard the relay. Yeah, so the one where I did not have continuity between, maybe this is the control pin or something. I don't know what that's called, but that's the one that's bad. Alright, I've already shown I'm doing load testing. I'm going to go ahead and go through a load testing on this one. This is power supply number 3, where we had the most trouble with, just like I did on power supply 2. If I find anything interesting, I'll come back. Otherwise, this will be the end of the video. So 2 power supplies fully working, repaired, tested, etc. And then I have the first one, number 1, that had some problems that I'll film in a different video probably.